Yeah, welcome to VLSS Simplified YouTube channel. So I want to explain about this bit level logic operators. Okay, bit level operators. So bit level operators are nothing but it will do the bit level operation with each and every bit. Okay, so in bit level operators you have AND operator, OR operator, XOR operator, XNOR operator, and NOT operator. So I want to explain this execution of some sample programs, the bit level operator by using Xilinx Vivado. So here first I want to explain this bit level and okay. So this is the program. So it will do. I already explained in this previous session about this program. I think you can go through that program series. Once I will explain. So here, if you see, okay. So if you see, so module bit level NAND, this is the nothing but identifier. So you are initializing reg 2 is to 0. This is 3 bit A, B, C, and reg is the data type, and 2 is to 0, that is X, Y, Z. Initial begin, and A equal to 5 means what? It will take the value as the 101, and 3 B equal to 3 tick binary 111. So A equal to 5 means it will convert into binary, that is 101, and C equal to tick bx, that is don't care, and bit level operation x equal to, so that means only one ampersand will be there. So a and b, y equal to a and c, and z equal to b and 0. So I want to display this outputs. For displaying this outputs I need to use a dollar display. The value of x is percentage b, the value of y is a percentage b. B is nothing but binary, so I want to display the values in binary. That's why z is percentage b, x, y, z, and end module. Okay, so this is the program I'm going to execute in the simulation part by using this Xilinx Vivado. So whatever the program you are going to execute in the simulation sources, you need to make this as a top module. So this bit level and I'm making as top module. Go to run and run simulation. Okay, so it is executing the simulation part. You can see the output in the TCL console. So it is executing. So in the TCL console, if you see, so see this TCL console. So here x equal to 101, okay, and y equal to x 0x and z equal to 000, okay. So this output also theoretically I did in the previous session in the logic operator and bit level operator. So you can go through that session, and you can see this result. You can compare with this result. Okay, this is the result we got in the simulation part. Okay, so this is about the bit level and operation. I'm closing the simulation part. Yeah, so next bit level or I want to execute, so I need to make this as top module. Here I'm making this as top module, bit level and in simulation sources. So it is I made this as a top module, and go to simulation, run behavioral simulation. Just a bit level or means what? That and will be converted into oblique or. Okay, I'll show the program. Just we are going to execute in TCL console. See here. So the output, I'm taking the same inputs only. Okay, so here if you see, so here the value of x is what? 111, and the value of y is 1x1, and the value of z is 111. Okay, this is the result of bit level or operation. Bit level or operation, the theoretical part you can see in the in my previous video. So if it is bit level or, you can see here, this is the program. This is the program. You can see this is the program. So just whatever the inputs are there, I'm giving same values. Just that bit level and converting into this or operation. This is the symbol for bit level or. Okay, just oblique. Okay, this is the symbol for bit level or. Okay. So next, I want to execute bit level XOR. I'm making this as top module. Okay, bit level XOR. So BitLevel XR, I'm making this as top module. And if you see the program, so just what is the change I need to do in this BitLevel XR operation? So if you see, this is the symbol for XOR operation. Okay, this is the symbol for XOR operation. Okay, so x equal to a XOR b, y equal to a XOR c, and z equal to b XOR c. So the same inputs I am giving, and a dollar display whatever the values I want to display, so that I am giving in the dollar display. Okay, so this is about the bit level XOR. So I want to execute this. I want to run the simulation. So run the behavioral simulation. So in the TCL console, we'll get the output. If you see the TCL console, I'm expanding. Yeah, here if you see, this is the value. The value of x is 0, 1, 0, and the value of y is xxx, and value of z is triple one. Okay, so this you remember. So if you are going when you are doing with the XOR operation, just you will get the complement of this one. So that means you'll get 101 and xxx is say 000. Okay, so this is the output of bit level XOR operation. Okay, so this is the output of bit level XOR operation. So I'm closing the simulation part. So next I'm going to execute this bit level XOR operation. I need to make this as top module. Okay, so if it is bit level XOR operation, so see the program. So one second. XNOR, no? Okay, XNOR operation. You see this program. So this is XNOR operation. So that means, so there are two symbols are there. So that means not of XOR, or we can use as XOR NOR. Okay. So anyone it could be. So x equal to a XNOR b, y equal to a XNOR c, and z equal to b XNOR 0. Okay. So these are the operations I am using. I am giving the same inputs: a equal to 5, b equal to 3 tick binary, and triple one, and c equal to tick bx. Okay. So this one I want to run the simulation. XNOR operation. So XNOR operation, if you run the simulation, and then I want to see the outputs in the TCL console. Okay. So in the TCL console, if you see the outputs, see here. So previously you got the output as for XR, you got 010, no? So the just complement of that one. So complement of XR is nothing but XR, no? So 010 you are getting, and XXX you are getting, and 00, so all ones you got, so 000 you are getting. Okay, so this is the output of XOR operation. Okay, so this is the output. I'm closing the simulation part. And the last one is logical not operation, sorry, bit level not operation. So if you see the bit level not operation, it will do the not operation with each and every bit. Okay, so see here. So that means what is so you can expect the output. So a equal to 5 means what? 101. So not of 101 means what? 010 you need to get. Okay, and b equal to 3 tick binary. All ones means triple ones means you should get all zeros. Okay, just changing. It's like a ones complement, no, changing zeros to ones and ones to zeros. Okay, not of it. Bit level operation. Z equal to the not of c means so the don't care condition is either 0 or 1. Okay, so you are getting xxx only. Okay, it can't decide either it is 0 or 1. So the not operation of this one is you are getting xxx. Okay, so this is about bitwise not operation. So whatever the program you are going to simulate, that you need to make as top module. So set as top module. Bitwise not I'm making as top module. Yeah, this one I'm making as top module. Go to simulation, run the behavioral simulation, run the behavioral simulation, and see the output in the. You can see the output in the waveforms, or you can see you are getting the outputs in the waveforms, or you can see in the TCL console. Suppose if you want to see the output in the waveforms, you need to make this as fit to page, and You can zoom it. Okay, so these are the outputs you can see. And here I am seeing the TCL console. So here you see these are the output 5 7 and X. And in the here you are getting 2 0 and X. Okay, 2 0. So that means 1 0 1, that is 5. So you are getting 0 1 0, so that is 2. Okay, and 1 1 1 you are getting 0. Okay, 0 means what? 1 1 1 complement of 1 1 1 means 0. Okay, you got 0. And z equal to what? Z equal to X. Okay, those values you will get in this simulation part. And you can see in the TCL console also. Okay, so if you see, if you see the output, if you see the output, so see here, the value of X is what? 0 1 0, and the value of Y is 0 0 0, and the Z is X X X. Okay, this is the result for bit level not operation. Okay, so like this, you need to see the outputs for the bit level operations by using Xilinx Vivado. Okay, so hope you understood this about. So any doubts or any queries, you can click on the comment box. I am ready to clear your doubts. Okay, thank you.